Hello, guys. Yes, I want to explain something that is of good interest to us, because I know some of us might be wondering, how do I know the two equations to generate before I can convert recurring numbers to decimals? Recurring numbers to fraction. Recurring decimal numbers, I mean, to fraction. Now, when you look at this critically, look at these three equations, for instance. Well, what do you observe? You observe from these two equations that they are recurring numbers. That's the very first thing you observed, right? The first thing you observe is that they are recurring numbers, right? So now look at the very first one. For instance, the very first one, number one. What do you see? 0.5555, right? That question automatically becomes your first equation. So your first equation becomes x is equals to 0.5555. Now there is this thing. This is the first equation you are supposed to generate. Now you remember, whenever you move this decimal point, you take a step of all over 10. That's 10, right? When you move it to the second place, it becomes over 100. The whole of this figure over 100. You move it to the third place, the whole of this figure over 1000, and so on and so forth. Now the idea here is this. When you look at the number, after moving the decimal point, what is left at the right hand side, right? What is left at the right hand side must be equals to what is left at the right hand side of the previous equation. Then, so that when they subtract each other, it becomes 0. For example, once the decimal points move a step further, you generate the second equation, right? And that is more or less like multiplying this first equation by 10. So if you multiply this first equation by 10, you have 10x is equals to, let this decimal point move to this, that's 5 points, right? 555, that is 10 times this, which is the same thing as 10 times this. So this 10 times this will give you this. 10 times this equation will give you 5.5555. That's equation 2. Now observe. You see that everything at the right hand side is equals to everything at the right hand side. So when you subtract the two equations, everything at the right hand side will become 0. So automatically you have a whole number at the right hand side. So here becomes 9x, here becomes 5, right? Because everything here minus everything here is 0. So 5 minus 0 is 5. So with this, you have an answer which is 5 all over 9. So that is the trick in doing this, right? Just to make sure everything at the right hand side of your decimal, or after the decimal point, let's just put it that way, everything after the decimal point of both equations, we subtract each other to get 0. That's the trick. So no matter how you move the decimal points, after you multiply by either 10, 100 or 1000, because those are the multiples you use multiples of 10, 100, 1000, and so on and so forth to shift the decimal point and generate the equation. But the most important thing is, everything after the decimal point in both equations, when they subtract, do they give 0? If they do, then you are good to go. Okay, so looking at the second one, what do we see? 5.333, and that's the first equation, which is equals to x equals to 5.333, right? Keeps going. That's the first equation. So the second equation, if you observe, if you multiply this by 10, remember I told you it's multiples of 10. You have 10x, then you multiply the right hand side by 10, meaning that the decimal point will move a step, which is 53.333. So if you do that, the question is, after the decimal point for the second equation, will the numbers be the same thing as after the decimal point for the right hand side of the first equation? If this is the same, then it's good to go. So you have 10x is equals to 53.3333. So check. After the decimal point for the first one, is it the same thing as after the decimal point for the second one? If yes, then it's good to go. In this case, it's yes, then it's good to go, right? So then we'll move to the third one. Observe the third one. The first equation is x equals to 15.5444, right? Then it keeps going. It's question 1. So now, if you move the decimal point a step further, that will be 10, right? So it will be 155.44. So will it be the same thing as the previous one? Will you have the same thing as the previous one in this case? So where you have 15.544, those are the things you check. Will it be the same? So if you use 10, you use 1,000, you use 10,000. So there are cases where there could be slight changes, right? If in this case you have, do for 10, it's going to be 1555.444. Then you do for, so you do for 1,000 or 100. So what do you have? So you have 155.444. So this is what you have for equation 2, equation 3. So how do you solve a case like this? Who can think? Yes, you're right. We can pick equation 2 and 3, right? Then subtract equation 2 and 3. Remember, this equation 2 and 3 came from equation 1, right? So we multiplied equation 1 by this. You got this. Equation 1 by 100, you got this. So if you use equation 2 and 3, definitely you generate something. Probably you can try it yourself. Let's try it yourself and let's see the result you get. So now we'll go to the third one. The third one says 17.73444. How do you deal with that? The last one, you know, the very first equation is x equals to, you just repeat the question, right? 17.7344 and keeps going on and on. So we can multiply this with the first multiple of 10, right? If you multiply this equation 1 by 10, you end up with 10x is equals to 17. Observe, the decimal point has to move, right? So you have 177.3444. So you ask yourself that question. The right hand side of this, is this equals to this? Obviously no, right? Obviously no. So you have to take it a step higher again. So you can't work with these two. So let's take it a step higher. The second multiple is 100. So 100 times x becomes 100x is equals to, so this decimal point will move twice, right? So you have 1773.444. That's equation 3. So you ask yourself, can you work with these two or these two? The answer still is no. 444, you see, they are not the same thing. This is not the same thing with this. Neither is this the same thing with this. So you still keep on going. The next one is 1,000. So you have 1734.444. That will give you equation 4. So you then ask yourself, can I work with these two? How do you check? Look at the decimal point. After the decimal point of all of them, which ones are the same? Whatever is the same, you bring them together, then you continue solving. So this is the same thing with this, right? So you can pick equation 3 and 4, then you can continue solving. So this is just the trick. I hope with this you've gotten an idea, a simple trick of how to solve. I will leave this for you to work so that you can, because mathematics is all about practicing. But I really beg you to please try, subscribe to my channel, tell your friends, because there are tricks you will learn, things you will learn in maths that honestly you will so much appreciate. Thank you for watching. Please like and subscribe. So what I will do in my next video probably is just try and see how I can convert maybe one of these back to the decimal. So you see that it is probably, I'll just pick the answer to one of my question and convert it back to the recurring decimal. So you see that is the truth. You can even punch it on your calculator and test it yourself. Discover that these things I'm saying, they are very insightful. Thank you very much for watching. Till we see you then next time on Maths World.